Algebra 2, Lesson 90, Systems of 3 Equations. So we've solved problems in the past where we had 2 systems of linear equations. Now we're going to start solving problems like this, where we have 3 systems of equations. And these are not linear equations, these are actually plain old equations. You'll notice that with the x, y, and z. So we have 3 terms, and we have 3 equations. So, this is not going to change. We're not actually learning any new methods of math. We're just applying old methods of math in new, scarier problems. So rules don't change. All of our rules of algebra and equations are still the same. We just have to use them in a little bit tougher problem. So when you're solving 3 systems of equations, like the ones we have here, one of the best methods to use is elimination. And if you can, eliminate one term from 2 equations all at the same time. What I mean by that is try to find a variable that you can eliminate twice. So in this case, I'm looking at the different equations, and I've got a few different options here. I've got 2x, x, and x. So I mean, I could try to multiply this one by 2, and then, or I could try to multiply both of these equations by -2, and in that case, they would both be canceled by this third equation. Or I've got -y, positive 2y, negative 2y. What I could do, which is what I'm probably going to do, is I can multiply this equation by positive 2. So then I have 2 negative 2y's and 1 positive y. The z's are a little bit tougher because I got to start multiplying by 3. So I'm going to go ahead and do this y equation. And I'm going to start off with elimination because elimination is a lot easier when you're dealing with 3 systems. So I'm going to start by multiplying this first equation by 2. So when I multiply 2x by 2, I get 4x minus 2y plus 6z equals 18. All right. So now that I've rewritten that equation, I can now take this equation and add it to this middle equation, and I will eliminate the y. And then I can do the same thing with this equation. I can add it to that one and eliminate the y. So that's what I'm going to do. We will take this middle equation. I'm going to write it here twice, and then we'll eliminate the other 2 equations from it. So this middle equation is x plus 2y plus z equals 8. I'm going to write that twice. And then I'm going to take this equation, and I'm going to write them underneath it. So this original equation here goes down below. X minus 2y plus z equals 0. And this equation is going to go down here. 4x minus 2y plus 6z equals 18. Now when I add both of these, I'm going to have 2 equations that only have 2 unknowns. So here, x plus x is 2x. That cancels. Z plus z is 2z. And 8 plus 0 is 8. Here, x plus 4x, 5x. These cancel. Z plus 6z, 7z. And then, let's see here, 8 and 18 give me 26. So now that I've got 2 systems of equations that don't have a y in them, I can then start solving again, or I can start trying to eliminate again. Let's see here. I'm going to eliminate the x terms because I can see the greatest common factor here would be 10, and then 5s and 2s are a little bit easier to multiply than 2s and 7s if I was to eliminate the z's. So I'm going to use elimination again, and I'm going to change both of these equations. This one I will multiply by -5 to give it a negative coefficient. This one I will multiply by +2 to give it a positive coefficient. So this one, when I multiply by -5, I get negative 10x plus 10z equals negative 40. Oh, sorry, not plus. Minus 10z. Forgot about the negative. Okay, and then this one, when I multiply, I get positive 10x plus 14z equals 46. No, sorry, 52. 52. So I'll continue the elimination process by adding these 2 equations together. let's see here, what color have I not used yet? Red. So when I combine these, the x's cancel. Negative 10z plus 14z gives me 4z. And then negative 40 plus 52 gives me 12. So I divide by 4 on each side. And then z equals 3. So I've got one of my answers right here. Now that may have seemed like a lot of work to just get one answer, but as you guys should know by now, once you get one number, the rest kind of fall into place very quickly. So once I know that z is equal to 3, I can plug that back into either one of these equations, and I kind of work backwards now. So if z is equal to 3, then I can go to this equation, and I can write that 2x plus 2 times 3 is equal to 8. So 2 times 3 is 6. So if I subtract 6 from each side, that cancels, and I get 2x is equal to 2. So if I divide by 2, then I get that x is equal to 1. So now that I know two answers, I can take both of these and plug them into one of these equations. And I'll go ahead and I'll use this original orange equation that I was using before. So instead of writing x, I'll go ahead and write 1. So 1 plus 2y plus z, which is 3, is equal to 8. These combine to become 4. So this equation is now 2y plus 4 equals 8. If I subtract 4 from each side, I get 2y is equal to 4. I divide by 2, and then I get y is equal to 2. So I've got my third answer. Now, when it comes to writing your final answer, it's not good to do this. I know some of you are still in the habit of writing your answers like this. We want to write them in an ordered pair. So our final answer should be written in the pair x, y, z. So, or sorry, not pair, ordered triplet. So we'll put 1, comma, 2, comma, 3. And that is our final answer. All right. Yep, that's it for this lesson because that's a lot of math to go through. If you have any questions, let me know on Moodle, and I will see you in class.